indefinite integrals, those are integrals slightly different in one way from our definite integrals that we've been talking about. The definite integrals had the upper and lower limits. So we had integral a to b f of x dx. So we had upper and lower limits. An indefinite integral, that's an integral without those limits. There's no upper limit, there's no lower limit. It's just the integral f of x dx. All right? Well, it sort of, in most of our cases anyway, it shortens our process, because what this amounts to then is when we evaluate these indefinite integrals, we don't have to plug in the upper and lower limits. So it does shorten it, our problems just a little bit. We just have to find the antiderivative, because yeah, what this will be then, the integral of f of x dx, well, it will be that antiderivative. We call it big F for little f. The antiderivative is big F. However, the one thing we have to go back to is, since we're not plugging in those limits, these indefinite integrals, we're going to have to include the plus c, because for the definite integral, the plus c would cancel out when we evaluate it. Well, since we're not plugging in those limits, it doesn't cancel out, so to speak. So anyway, that's the one little catch. We are going to have to go back to adding in our plus c for our antiderivatives. But it's a trade-off, I guess. So yeah, if I just do the indefinite integral of x squared dx, the antiderivative is 1/3 x cubed plus c. Yeah, I'm not plugging in anything there, so that's the answer. Okay. So once you get the antiderivative, you're pretty well done there, if you can do the antiderivative of this. One thing this opens up, I guess you might say, is to talk about is, you have in the back usually of most calculus books, you have a table of integrals. In our book, it's kind of it's got the little gray, blue edges, I guess. Maybe gray edges. Yeah. Yeah, in our book it starts about reference page 6 there. A table of integrals, and it runs for several pages. We're not going to, of course, talk about all those rules or all those forms, 4 or 5 pages there of integrals. The ones that will pertain to us right now anyway are the trig integrals. We haven't done any in lecture here, but we've talked about them before just in terms of antiderivatives, but now we can talk about them in terms of integrals. The integral of sine of x, that would be cosine of x plus c. The integral of cosine of x dx would be negative sine of x plus c, because it's the antiderivative. Probably has listed their tangent. Nope, maybe not. Yeah, it does list the tangent, but we're not going to have to deal with those. That comes in for our courses in the second calculus, Calc 2. But it's on there. You can see what it is without being explained. But the one after cosine is secant squared. I think they're using x's, I mean u's instead of x's, but same difference. Yeah, secant squared has a nice one because that's just tangent of x plus c, because the derivative of tangent is secant squared. The antiderivative of secant squared is tangent, so that's why that integral is that. You got the secant x, tangent x, dx would be, that integral would be, that's just secant. And it keeps on listing in those tables, but anyway, that you see indefinite integrals in these tables of integrals. All right. Now, the good news is the same thing applies for these indefinite integrals as the definite integrals, in that if you've got addition and subtraction in your integral, that's pretty nice. So yeah, if I've got the integral of 9x to the fourth plus 7x cubed minus 5x, that's what I want the integral of, I'm in good shape. Because that integral, since it's addition, subtraction, I just have to do the antiderivative of each. And then add the plus c, and I'm good to go. So that would be antiderivative, add 1, so it would be 9/5 x to the 5th. Add 1, so it would be 7/4 x to the 4th minus 5/2 x squared. And since it's indefinite, put the plus c. We're good. All right? So that still pertains. Unfortunately, though, still pertaining is the fact that, yeah, your integral, if you have f of x times a g of x, two things multiplied, unfortunately, that does not amount to the integral of f of x times the integral of g of x. Just doesn't work. Neither does it work for divide. So I've mentioned that several times now, so hopefully we'll get the point. Yeah, you just cannot do division and times as that, such as that. So, again, what do you do? Well, if you've got a time, and you can get rid of the times, then so let's say I've got the integral of x squared plus 1 times the x cubed minus 27. That's times. Not able to do the antiderivative as is. But if I pull that out, I don't have that problem, right? So multiply x squared times x cubed, that would be x to the 5th. X squared times minus 27 would be minus 27x squared. 1 times x cubed, that's x cubed, and then 1 times minus 27, minus 27. Yeah. So now it's not times, it's just minus plus minus. Or in reorder if you want to. So yeah, now I don't have that problem. I don't have multiplication, antiderivative. I'm just talking antiderivative of sums and differences. Okay? 1/6 x to the 6th, 27 over 3 x cubed, 1/4 x to the 4th, minus 27x. But again, once I do the antiderivative of an indefinite one, indefinite integral, add the plus c. So if you put them in order, only thing here I see is that's minus 9. Okay? What about this one? What about the integral 3x plus 5 squared dx? Well, actually there's a couple ways we can do this one, but only one way that we've talked about so far. The other way comes up next time, but yeah, this is very similar to that one just right there, if I look at it that way, because doesn't this mean the integral of 3x plus 5 times 3x plus 5? Yeah, and so essentially what I've got here is times. So if I look at it that way, I can do this one because I can just FOIL that out. So that's the integral, that would be 9x squared, 15x, and 15x is 30x, plus 25. Now it's just simple antiderivative power rules. So the new power there would be x cubed, so I divide, so it would be 3x cubed. New power here would be x squared, so I'm dividing by 2, so it would be 15x squared. That would be 25x, just have to add the x for the antiderivative there, and then add the plus c. You got it. Yes? All right. Well, one more time here. If you've got divide, it's not just a simple antiderivative. You got to somehow get rid of the division, or there's other possibilities that we'll explore a little bit next time. But yeah, we can't do the antiderivative as is. But what I can do is divide those separately by the square root of y here, the denominator. See what that gives me. Well, again, it's it'd be subtraction here. You got y to the 1, that's y to the 1/2. So what I've got here is 1 minus a half, so that's just be y to the 1/2. And then here that would be y to the minus 1/2. Oops, dx. Should be dy's. For that to be dx, it's dy. That'd be something else. Altogether, but so yeah, now it's just power rule. Be 3, the new power here, 1/2 plus 1 would be 3/2. So I'd multiply by 2/3 up front. The new power here would be 1/2 power, right? Negative 1/2 plus 1 is 1/2. So I'd multiply by the reciprocal 2 over 1. And then do the plus c. Clean it up, it'd be 2y to the 3/2 minus 10y to the 1/2 plus your c. All right? So that's one thing we can do for division is get rid of it. All right, well.